So, polynomial division is kind of similar to regular division, but there's much more involved, and we're going to talk about the remainder theorem. Okay, that's what this is entitled, is the remainder theorem. So number one, we have a function f of x, and it says evaluate each function at the given value. Well, there are several ways to do this. We could plug 2 in. We could graph it. And when we graphed it, we could find the point, the y value at x equals 2. We could look at the table. There are lots of things to do. Okay? But we are using division, and we are assuming that this is a root. We're just going to assume that 2 is one of the roots. Now, it may or may not be. We're going to find out in a second if it's actually the root. So, if 2 is the root, what is the factor associated with that root? X minus 2. So we're going to divide the polynomial by x minus 2. So again, we're just assuming that it is a root. Whether or not it is in a minute, well, that will be our answer. So x minus 2. Yes, we will know in the end if it's a root or not. So yeah, I told you, you're not going to do it this way in real world, in the real life, but no, never. So negative x to the third. How many times does x go into negative x to the third? Negative x squared. Negative x, so this would be 2x squared. And I need 2x, the 2x squared diagonal to add up to be 0. So I need to put a negative 2x squared in there. And then that's going to give me a negative 2x. Negative 2x times negative 2 is 4x. And I need my x diagonal to add up to be 6. So this would be 2x, which would give me a plus 2. And 2 times negative 2 is negative 4. So my remainder is going to be negative 3. So, does the graph cross the x-axis at x equals 2? No, because I had a remainder. Well, guess what? If it would have touched, what would my remainder have been? 0. And that corresponds to the point 2 comma 0, right? So the point is actually 2, negative 3. Now, that's the long way, right? But we're just practicing division and understanding how division fits into this whole setup. So you have to use division, and your remainder is going to tell you two things. First of all, it'll tell you if that number's a root, and second, it will tell you, if it's not a root, the value of f of x at that point. That's what the remainder theorem says. If you take a polynomial and you divide it by any factor associated with a particular root, the remainder from that division is going to be the y-coordinate of the function at that root, at that number, at the x value. And again, it is a long way to get there, but really what we're doing is practicing division. The thing you have to remember is the root and the factor will have different signs. That's a really common mistake. So if they give you x equals 2, you have to divide by x minus 2. Landon, did you have a question? Well, the only way to get a remainder 2x plus 4 is if you divide it by an x squared, and you're testing two roots at the same time, which is not what we're going to do today. So the remainder theorem makes you check one root at a time. Well, yeah, well this one has that, right? This is plus negative 3 over x minus 2. How you know that's gay, I'm not sure. But I asked it and it wouldn't tell me. So.
It came
Okay, so that's the first three. If you look at the next ones, so state if the given binomial is a factor of the given polynomial. So you're just going to divide it. How do you know if it's a factor? If the remainder is 0. Okay, so this is really just yes, no. So this is just another division problem, but then you have to interpret the answer. No. Okay, turn to the back. No, you are. But then the answer is either yes or no. If there's a remainder, it would be no. And if there's not a remainder, then it would be yes. Okay, and this one is actually saying divide. So really, you're doing the same thing on all sets. But the first one, your answer is the remainder. Whatever the remainder is, that is the value of the function at that particular point. On the second set, you're just deciding did it go in evenly or not, which you do division and you say yes or no. On the third set, you just divide, and your answer is your answer. Yeah. Well, you'll do all the work, and then you'll say y equals, or f of x equals, the remainder. No, evaluate each function, so we want, yeah, y equals is the answer. Yep. But you do need to do the division. Okay, and then later we will do more using division. Yes, sir. Okay. Good luck.